Welcome to question 3 of the 2006 Mathematical Methods Exam 1. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAA. For question 3, it says let f of x equal e to the power of cos of x, and we're asked to find f dashed of x, or the derivative. So the first thing we need to do is recognise this is a composite function, therefore we're going to use the chain rule for differentiation. So to use the chain rule, we're going to let y equal e to the power of u, where u is the inner function, which in this case is cos of x. Next we're going to find the derivative dy du, which is simply e to the power of u, and the derivative du dx, which is equal to negative sine of x. From our formula sheet we know that dy dx is equal to dy du multiplied by du dx. Therefore the derivative f dashed of x is equal to dy du, which is e to the power of u, so that's going to be e to the power of cos of x times negative sine of x. And we can just clean that up slightly by expressing that as negative sine of x multiplied by e to the power of cos of x. Therefore f dashed of x is equal to that expression there. And for 1 mark you can simply state that answer. In the examination report we can see that roughly 50% of students got that mark, and given that it was a standard application of the chain rule, the question was not well answered. Often x was not included in responses, raising the question as to whether students understood circular functions. There were also many common incorrect responses, and some students even attempted to use the product rule. For part B, we have let y equal x tan of x, and we're asked to evaluate dy dx, the derivative, when x equals pi over 6. So for this question we need to recognise that that is two functions multiplied together, therefore we'll use the product rule for differentiation. So in this question we're going to let u equal the function x and v equal the function tan of x. Therefore du dx, the derivative of u with respect to x, is simply 1, and dv dx is equal to 1 divided by cos squared of x. So also on the formula sheet is the product rule, which says that the derivative d dx of two functions u multiplied by v is equal to u times dv dx plus v times du dx. Therefore the derivative dy dx for this question is going to equal u, which is x, times dv dx, which is 1 on cos squared of x, plus v, which is tan of x, times 1, which still remains as tan of x. Next we need to evaluate the derivative dy dx when x is equal to pi on 6. So that means we're just going to sub pi on 6 into the rule we had above. So we're going to have pi on 6 multiplied by 1 over cos squared of pi on 6 plus tan of pi on 6. Next we need to remember our exact values for our circular functions. So we have pi on 6 multiplied by 1 over, and pi on 6 for cosine is going to be root 3 on 2, and then that value is going to be squared because it was cos squared of that value, and then we add on tan of pi on 6 is equal to root 3 over 3. Next we have to simplify this expression, so we're going to have that this is equal to pi over 6 multiplied by, and root 3 over 2 squared is 3 divided by 4, and if we divide 1 by that fraction it's the same as multiplying by 4 over 3, and then of course we still have our plus root 3 over 3. Simplifying that down we have 4 pi over 18, which is 2 pi over 9 plus root 3 over 3. So the last thing that we could do to this would be to write it as a single fraction, so we'd have 2 pi plus 3 root 3 all divided by 9. So that is the derivative dy dx evaluated at pi on 6. From the examiner's report, we can see that about 30% of students receive full marks and another 30% of students receive 2 marks. So many students were able to obtain the correct derivative using the product rule, but could not complete the corresponding evaluation successfully. This was usually a result of not knowing the required exact circular functions values, or not being able to handle subsequent working. Occasionally students attempted to use the chain rule or incorrectly applied the product rule, simply multiplying the 2 derivatives. Some students had difficulty in simplifying the expression as it contained a surd. So the take-home message from that comment is you need to know your exact circular functions values, and you need to be able to do the appropriate arithmetic with them. So you need to be able to multiply, square them, add and subtract those fractions.